Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 1 to 5 of the January 2019 Algebra 1 New York Regents exam. In this presentation, we're going to be going over the problems in a step-by-step fashion. If you need a faster explanation, just look into the description below, and we're going to be adding on a much rapid coverage of the solutions to this examination. Alright, so question number 1, this one focuses on how to graph and use the lines of best fits with a given data set. The question reads, the scatter plot below shows the relationship between the number of members in a family and the amount of the family's weekly grocery bill. Okay, so we have the data set right here. Question, the most appropriate prediction of the grocery bill for a family that consists of 6 members is... So what we have to do first of all is generate a line of best fit, and then we can use that line to determine what the output is for the specified input value of 6. Okay, so basically what we're trying to do is approximate what y of 6 is. So find the approximate value of y evaluated at x equals 6. So that's what we're trying to do. All right. So the first thing we're going to do is we have to draw the line of best fit. Now, something you want to recall is how to draw a line of best fit. The first thing you do is you have to note that the line of best fit follows the trend of the points. Okay. What do I mean by trends? There are 4 possible trends that you can have, and these are them. Either it's a positive trend where the line is going up, that's a positive trend. You could have a negative trend if the line is going down. Remember, you always go from left to right. You can have a horizontal trend where in this case the slope is 0, or you can have a vertical trend. Okay, or in this case it's undefined. In this particular case, can you see what the trend is? Is it positive, negative? Is it horizontal, or is it undefined? So all you do is just draw a shape around the region, around the points. So I'm going to draw it something like this. Just follow the trend and draw the shape in such a way that you capture all the points. Alright? Alright, so what do you notice here? It looks like it's tilting upward slightly, right? So we can describe this trend as a positive trend. So we have a positive trend happening here. So that means that our line of best fit will follow a positive pattern. All right? Now, the next thing to keep in mind when drawing your line of best fit is you want to try and split the area of the figure you generated to the best of your ability. Another way to think about it is try to get an equal number of points on the top and on the bottom as much as possible. It's not going to be perfect, okay? So taking a look at the points that we have here, I'm going to try and draw a line of best fit. Remember, this is an approximation, okay? If you follow the same procedure, there are infinitely many possible solutions, but they all will look similar. All right, so following this pattern, I know the line of best fit is going to be going up slightly like this. So let me try and get as much equal number of points on the top as there is on the bottom. All right, so I'm going to start from the bottom right here, and then just follow that trend pattern as much as possible. So this is a possible line of best fit that we have right here. Okay, so try and get as equal number of points on the top and bottom as possible. So this should suffice. Now what we're going to do is we're going to use this line to approximate what the output value is for an input value of 6. Okay, it's specified here. It says for 6 members. So we're going to start with 6. We're going to trace this to the graph, and then we're going to trace it horizontally to the output value to see what the answer is. Okay? All right, let's go ahead and do that. So we have, let me use a, have blue already. Let me just use a green line. All right, so make it skinnier. All right, so your input value trace directly to the You trace it directly to the line, and then you trace from the line to the y-axis. Okay, so this is your inputs to the line right here, and then your output is the horizontal line right to your y-axis. Okay, so we can clearly see that the output value is somewhere close to 300. All right, so this is what the output value is. So this tells us that for a family that consists of 6 members, their grocery bill will be around $300. All right, so that's exactly what it's going to be. Now let's go ahead and write down the expression for that. So we're going to have y, the output evaluated at 6 is approximately 300. If you look at the options that we have here, we can see that our answer is option number 2. Okay? So this is how you generate lines of best fit, and if you want to use it to evaluate input values, just trace your x-axis to the graph, and then vertically to the graph, and then trace it horizontally to the y-axis to see what the specified output value is. All right, let's take a look at question number 2. In question number 2, we're going to be working on how to evaluate functions and the utilization of the order of operations. Please excuse my dear Aunt Sally in simplifying the resulting expression. Okay, so a caution to keep in mind when evaluating functions is you always want to use parentheses to avoid making mistakes. Okay, so what are we talking about here? Let's take a look at the function under consideration. We have g of x is equal to negative 2x squared plus 3x. The question says, what is the value of g of negative 3? So g of negative 3. So what's happening here is we are inputting negative 3 into the function and trying to figure out what the resulting output is. All right, it's similar to the previous problem, but we're doing the same process algebraically here. Okay, so we have negative 2. What's going to happen is all the spots that have x's, we're going to take out the x's and replace them with parentheses. Why are we doing that? Well, it's because we're going to substitute the new x value, which is negative 3, into the empty spaces. So you have g of negative 3. This input value right here is your x value. So x is basically negative 3. So we're going to take this particular x value and we're going to put them into the x positions. All right, think about it as substituting. All right, so the first x, instead of x squared, we have negative 3 square, and then 3x is 3 times negative 3. Notice how I put parentheses around this values that I substituted. It prevents me from making mistakes when I'm evaluating the expression using the order of operation. Okay, so we have, please excuse my dear Aunt Sally. Parentheses, exponents, multiply, divide from left to right, and then add and subtract from left to right. Okay, so we're going to PEMDAS this expression real quick, and that will give us our final answer. Now, another thing that you want to note is that when you take a negative number and you raise it to an even power, your answer is always going to be positive. Okay, that is because all your negative signs can be paired up into 2's, and when you multiply 2 negatives, you end up with a positive. When you raise a negative number to an odd power, your result will be negative because there's always going to be one minus left hanging, and all the other minuses will be paired up and they will all become pluses, and that one minus remaining will cause the entire product to be negative. Okay? All right, with that in mind, let's simplify this expression right here. So we have negative 2. Now, what is negative 3 raised to the second power? Negative 3 raised to the second power is positive 9. How so? Negative 3 squared, just think about it as negative 3 multiplied by negative 3. Okay? And then we have positive 3 multiplied by negative 3. Remember, whenever you're multiplying different signs, you always end up with a negative. Okay? So we have negative 9 here. And then, let's see. This becomes negative 2 Now let's multiply these two together, this minus and this minus. Minus 3 times minus 3 is going to be positive 9. So you can see clearly that negative 3 raised to the second power resulted in a positive result. Okay? And then we'll bring down this minus, minus 9. Following order of operations, we need to multiply first before we subtract. So we multiply negative 2 and 9. Negative 2 times 9 is negative 18 minus 9. Since the signs are the same, you add and keep the sign, and your final answer will be negative 27. Answer to question number 2 is option number 1. Okay, now how can we do this with a calculator? Well, there are two ways you can do this with a calculator. You can either use the table or you can evaluate this from the home screen, okay? So what we're going to do first is store negative 3 in the x value. So negative 3, we're going to store it in x. Press enter. And then we're going to enter this expression in the calculator, negative 2x raised to the second power plus 3x, and press enter. And then we see what the answer is. Okay, so you can also evaluate expressions using the home screen in your TI-84. So just remember to store the constant in the variable first, enter the expression, press enter, and then it will calculate the answer for you. So we can clearly see that the answer to this question is option number 1. All right, let's take a look at question number 3. In this problem, we're going to be learning about how to carry out operations and classifications of rationals and irrationals. Okay? We're going to carry out operations, and then we're going to proceed to classify our final result as either being rational or irrational. Question 3 reads, which expression results in a rational number? So that leads us to the question, what on earth is a rational number? So over here, we have examples of what a rational number is. So first of all, a whole number is a rational number. A repeating or terminating decimal is a rational number. A quotient, sum, product, or difference of a combination of 1 and 2. Okay, since they're already rational, so if you have any operation, sum, difference, product, or quotient of two rationals, your answer will always be rational. And lastly, the root of a perfect square is also rational. Okay? All right, so let's go ahead and take a look at these problems. We're going to evaluate, carry the specified operation, and then we will proceed to classify. All right, before we do that, let's do a real quick review on our squares and square roots. All right? So review on squares. We're going to do squares and roots, okay? All right, let's start with squares. Now, what is 1 square? 1 square is 1. 2 square is 4. 3 square is 9. 3 times 3. 4 square is 16. 5 square is 25. 6 square is 36. 7 square is 49. 8 square is 64. 9 square is 81. 10 square is 100. So it's good for you to memorize your squares, okay, from 1 to 15 at least. And then it will really help you to carry out computations involving operations and radicals and also simplification of radicals. What do these numbers tell us? Well, it tells us what the roots are. So if you root the right side, you get the left side. Okay? So the square root of 1 is 1, as we can see. And this tells me that the square root of 4 is 2. This right here tells me that the square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. And square root of 100 is 10. So this just basically illustrates the inverse relationship between square and square roots. They're inverse processes, okay? All right, so let's get started. The first one, number 1, we have to evaluate this expression. The square root of 121 minus the square root of 21. So we know what the square root of 121 is, right? The square root of 121 is 11. But how about root 21? Can we simplify root 21? Are there identical common factors for 21? Well, let's see. If you break this down, 3 goes into 21 7 times. So we do not have a factor repeating itself in the decomposition of this number. So it cannot be reduced. So it stays just exactly as it is, 11 minus 21. And this number is irrational. Why is it irrational? Because the second term here has a square root. Okay, if you have that square root present in its reduced form, then it's irrational. Let's take a look at question 2, option 2. The square root of 25 times the square root of 50. Let's separate these, okay? So what is the square root of 25? Square root of 25, if you look at our list right here, square root of 25 is 5, okay? Square root of 50. 50 is not a perfect square. If you take a look at our list, 50 is somewhere here, okay? It's not a perfect square. But can we reduce this? Well, let's see. What we're going to do is decompose 50 into prime factors. Any factor that repeats, we'll group them together and bring them out as 1 because the square root of a factor times itself is just one of the factors. All right? So this is even, so 2 goes into 50 25 times. And then 5 goes into 25 5 times. Any number that ends up with 5, you can divide by 5. Now check this out. 5 repeats. Okay, so what is the square root of 5 times 5? The square root of 5 times 5 is 5. So these two break out of the radical, but 2 stays behind because it doesn't have a partner to break out with. So root 50 in its reduced form is the 5 that came out root the 2 that stayed behind. Okay? Right, now that we have our 2 radicals simplified, we're going to insert it back into the problem. So we have root 25 is 5 times root 50 is 5 root 2. Now to multiply these two numbers, what you do is you multiply radical with radical and the integer with the integer. So in this case, we have 2 integers here. We're just going to multiply 5 and 5 together, and your answer will be 25 root 2. Now, because of this root 2 component present, guess what? This number is irrational. All right, remember we're looking for what's rational. So 1 is not the answer, 2 is not the answer since they're both irrational. So we're going to keep going until we find the irrational number. All right. Okay, so let's do this. We're going to move on to 3. Option 3, we have the square root of 36 divided by the square root of 225. From our list here, we can see that the square root of 36 is 6 divided by, if you don't know what the square root of 225 is, and you're free to use your calculator, you can take advantage of that. So just enter square root of 225, and your square root is 15. Okay? All right, so 6 divided by 15, so 6 over 15. Now, is this number rational or irrational? Remember we talked about this earlier. If you have two whole numbers that are expressed as a quotient, if you divide a whole number by a whole number, guess what? It's irrational. Okay? We can simplify it further just for kicks. So divided by 3, divide by 3. In its simplified form, in its simplest form, we have integer. 6 divided by 3 is 2. 15 divided by 3 is 5. So a whole number divided by a whole number, it's rational. So ladies and gentlemen, this is the answer that we're looking for. Okay, let's just take a look at number 4 just to make sure. We want to find the sum of two irrational numbers, 3 root 5 plus 2 root 5. In this case, think about this for a second. What do you get when you add 3x plus 2x? what you do is that you just simply add the coefficients, right? And you get 5x. Well, the same applies here. Look at the radicals as x's. Okay? So 3 root 5 plus 2 root 5, what you're actually adding is just the 3 and the 2. So when you add 3 and 2 together, guess what? You get 5, and then you just add the root 5 component to it. 5 root 5. As you can clearly see, this is irrational also because it doesn't fit any of these descriptions here. That square root component there shows that it's irrational because you're not taking the root of a perfect square. 5 is not a perfect square. If you look at the list of numbers we have here, do you see 5? No, 5 is not there. So 5 is not a perfect square. Hence, the square root of 5 is an irrational number. Alright, so answer to question 3 is option 3. Alright, question number 4. In this problem, we're going to learn how to solve price quantity word problems. Question 4 reads, the math department needs to buy new textbooks and laptops for the computer science classroom. The textbooks cost $116 each, and the laptops cost $439 each. If the math department has $6,500 to spend and purchases 30 books, how many laptops can they buy? Okay, so let's see. So for this one, we're going to start off by writing down our formula. So the formula for this problem is as follows. Is a cost equation formula. So the formula is total cost. Total cost is equal to the unit cost multiplied by the quantity. Okay, so we have two unit costs here. Textbooks is $116 each, and laptops are $439 each. All right, let's go ahead and declare our variables so that we can utilize them in creating equations. All right, we'll start with assigning a variable to the quantity of textbooks. So let T equals the quantity of textbooks. Okay, and then let L equal what? The quantity of laptops, because we have laptops and textbooks as the two items that have been purchased. So what are the unit costs of each? The unit cost of textbooks is 116, and then the unit cost of laptops is what? The unit cost of laptops is 439. So we have all the information that we need to generate the equation. One last thing to note is the total amount spent. So let me see. Oh, 6,500. So the budget or total is equal to 6,500. All right. Now let's go ahead and write down the formula that we're going to use. We're going to adapt this formula right here to generate our equation. So the formula is as follows. The cost of textbooks plus the cost of laptops is going to be is either less than or equal to the total amount of money. All right, total amount of money you have to spend is also known as your budget. You can't spend money that you don't have, okay? So either you spend less than or equal to that target amount. All right, let's go ahead and solve this. Cost of textbooks, you simply multiply the unit cost of textbooks with the quantity. So that's going to be unit cost of textbooks times quantity of textbooks is 116 times the quantity, which is T, plus for laptops, the cost of laptops unit cost is 439 times the quantity of laptops, which is L, and that's less than or equal to the budget, which is 6,500. All right, so this is the inequality we're going to solve to determine how many laptops we can buy if 30 textbooks are purchased. Okay, so what are we trying to solve? If T, the quantity of textbooks, is 30, we want to find the resulting L value. All right, so with this equation right here, 116, instead of T, we're going to plug in 30. 116 times 30 plus 439L is less than or equal to 6,500. Okay, so multiply 116 by 30. You can do that in your calculator. You get 3,480 plus 439. L is less than or equal to 6,500. We're then going to subtract 3,480 from both sides and then divide by 439. All right, let's do it. So subtract 3,480 from both sides. We're solving an algebraic inequality right now. And then divide that by the coefficient of L. So subtract that out. And then that gives us 439L is less than or equal to, you can subtract that with your calculator, you end up with 3020. And then to get L by itself, you simply divide both sides by 439. Alright, so let's do it. So you divide both sides by 439, divide by 439, and then divide by 439. And then you get the answer, L is less than or equal to, let's do that with our calculators, 3020 divided by 439, we get 6.8793. Okay, so L is less than or equal to 6.8793. All right, so let's look at our options here. 11 is way out, 12 is way out. So which one are we going to pick? Are we going to pick 6 textbooks or are we going to pick 7 textbooks? Let's think about that for a second. Which is the correct answer? The correct answer is going to be 6. Why is that? If you have a budgetary constraint, if you have you don't have a whole number, you have a fractional result, you always have to round down. Okay? The reason why you round down when you have answers like this, so L is equal to 6, the reason why you round down is if you round up, you are going to exceed the budget. Okay? So this answer is telling us that we have enough money for 6 laptops, and then you have some money left, 0.8, but it's not enough money for the additional one to make 7. Okay? So when solving inequalities involving budgets, you always want to round down. Let me illustrate what I'm saying to you real quick. So we have, let's work with the original values. 116 times the number of textbooks, which is 30, plus 439, the cost of laptops, times the amount we said, which is 6, times 6, enter, we get $6,114. Is that within budget? The answer is yes. Now let's change it. What if we have 116x times 30? This is the total cost for textbooks, plus 439 times, now instead of 6, let's say we rounded this answer up, okay, to 7. Bam, we have $6,553. This is over budget. Where is that $53 going to come from when you just have 6,500? All right, so remember, anytime you're dealing with problems involving budget, you always round down because the fractional answer means you do not have enough money for the additional unit. All right, so the answer to question number 4 is option number 1. Alrighty, now let's take a look at question number 5. In this question, we're going to be solving an equation that has fractions and decimals in it. All right. So the question reads, it says, what is the solution to the equation 3 over 5 times x plus 4 thirds equals 1.04? Okay, so let's write that down. 3 over 5 times x plus 4 over 3 equals 1.04. Now, we can use a calculator for this one, okay? So calculators are allowed. Let's go ahead and start by clearing out this 3/5 right here. Okay, there are two ways you can do it. You can distribute and then isolate x, or you can eliminate this annoying fractional coefficient here first and then attack this one next. Alright, so that will save you a distribution step. You always want to take the fewest possible steps because it reduces the odds of you making mistakes. Okay? Alright, so fastest way is to eliminate 3 over 5 on the left and then eliminate the 4 thirds. When x is isolated, we have the solution. Okay? So the question is, how do you undo multiplication by 3 over 5? You undo multiplication by 3 over 5 by dividing by 3 over 5. Okay, so you divide by 3 over 5 and you divide by 3 over 5. Alright, but that looks like a mess. There is a more elegant way to divide by fractions. If you're dividing by fractions, is equivalent to multiplying by the reciprocal of that fraction. Drop, change, flip, right? So instead of dividing by 3 over 5, I can multiply by the reciprocal of 3 over 5, which is 5 thirds. So multiply by 5 thirds and multiply by 5 thirds. This is easier to look at, okay, as opposed to the weird expression that we had earlier. Now let's simplify this. This 5 divides with this 5, and then this 3 divides with this 3. On the left side, notice we've gotten rid of one of the annoying fractions, and we are left with x plus 4 thirds. Now on the right side, we are multiplying a decimal with a fraction. So this is where we're going to employ the use of our calculators. 1.04 times 5 over 3. And your answer is going to be 1.73 repeating. Alright, so let's write that down. 1.73 repeating. Last step, we want to isolate x, so we need to get rid of plus 4 thirds. So we're going to use the inverse operation. The inverse of adding 4 thirds is to subtract 4 thirds from both sides of our equation. Okay, so plus 4 thirds minus 4 thirds add up to 0. On the left side, we are left with x equals. Now on the right side, we are adding this two numbers, actually subtracting. So we already have the numbers saved here. Okay, all you do is just press minus, and it automatically populates the left side of this operation with the previous answer, 1.7333 repeating. That's what this answer means. It pulls in the previous answer minus the answer minus what we're trying to subtract, which is 4 thirds. Final result is 0.4. Okay, 0.4 is the answer. The answer to question number 5 is option number 2. So this is just a nice example showing how you can solve equations involving fractions and decimals with the help of a calculator. Thanks so much for taking the time to watch this presentation. We'd like to know what you think. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions, comments, or special requests for questions in algebra or any math course, just place it in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel for the remainder of this review series. More support resources can be found at our website, mathgotserved.com. Do check it out under the Regents page. Thanks again for watching and have a wonderful day. Goodbye.